Thank you very much, everybody. I'm very privileged to be here to the first edition of KCD. Actually, when they announced me that my submission was accepted, I was very happy. All right, thank you. We'll talk about how to scale Spark jobs on Kubernetes with Argo workflows and Argo events. I will use also a bit of a carpenter. All of these will be open source tools. So yeah, let's crack on. This is me. My name is Ovidiu. I'm working for AWS as a container specialist. I'm working with Kubernetes since version 1.9. This is how you count how many times, how long, okay, you're working with the Kubernetes. So for quite a while already. And okay, that's enough about me. All right, you are here, okay, not for me. You are here for my talk. So as a goals for this talk, we'll see how we scale, how we'll use the Kubernetes to for its scalability and agility to provision and to run Spark jobs, okay, into the cluster. And we'll see how we can do that in an automated way with Argo workflow and Argo events, the whole event-driven architecture. Okay, we'll see at the end. And because I want also for you to have something, okay, to take home. Okay, I will show you also a live demo, and it's live. I don't have a recorded one. I like to live dangerously. All right, so hopefully, okay, it will work. I mean, it was working 1 hour ago. All right, good. So let me start with the bits. Okay, I mean the main elephant in the room is the Apache Spark that is running on the Kubernetes. You guys are familiar with Apache Spark? Okay, only one hand. Okay, so it's good because you can learn something today. All right, okay, it's good. Apache Spark is it's an open source distributed computing system that is designed for data processing and analytics. And usually, apart from processing data and data analysis, Spark is also widely used in the machine learning and real-time streaming. All right. Okay, its versatility makes it popular among many data scientists that are running big data and complex data processing tasks. Usually, okay, obviously, when it was launched, it's still running as a standalone cluster, but it's limited with limited functionalities. Very much, okay, widely used as a Hadoop yarn, okay, running as a Hadoop yarn. And it was running on the Mesos some times ago, all right, okay, but now it is deprecated. And since in 2018, since version 2.3, it is running on the Kubernetes. And this is the preferred way, and I'm gonna see why it is the preferred way to run Spark on the Kubernetes. All right, okay, so there are many whys, okay, why you should run a Spark of Kubernetes, and I will just mention, okay, some of them. All right, okay, first of all, the Spark jobs, okay, there are some packages you built in a containers, okay, and you define all these packages in a Docker file. You all know these things, okay? And running these Spark jobs in a containers makes it easy, okay, to decrease the fact that the jobs, okay, can fail. Okay, so this is like a one thing. Second one, okay, you don't have to create clusters every time when you have some Spark jobs to be created, you are using the EKS cluster where you're launching your jobs. So you're reducing the launch time, okay, for these jobs as well. All right. And the fact that because you can use the Python for the jobs, and maybe you have different versions, so you can end up, okay, with different versions of Spark for some particular jobs. For some jobs, okay, you might want to have 3.3, all right, okay, and for some 3.4. Actually, in my demo, I'll have 2 independent jobs, and they will use 2 different Spark versions. The fact that you are going to use it, okay, with the containers allows you to have multiple versions. So you don't have to have separate cluster to run multiple if you have multiple versions for the Spark. Multi-tenancy, you have different teams, different jobs. You don't have to have separate cluster for that. So each team in his own namespace, how you did, what kind of multi-tenancy you're doing, the soft tenancy, hard hard tenancy. Okay, it's up to you. This is not a topic of the discussion, but these teams, okay, they can run their jobs in different namespaces, in isolation, into the same cluster. All right, and the fact that on the job itself, and another thing, you can put limits. Okay, you can leverage the limits and for the resources that you have in the Kubernetes. The last and not the least, obviously, is the efficient resource of utilization, okay, with auto scaling. And you'll see, like I have a cluster, okay, only with the core nodes, and when the Spark jobs, okay, kick in, they will see that all the jobs, the nodes are being created instantly, automatically. All right, okay, so you have the auto scaling. You don't have to have a whole cluster running in there and not used, okay, when you don't have jobs to run. All right, so what will be the internals of the Spark in the Kubernetes? First of all, okay, you can run Spark in you can run Spark in two ways into Kubernetes. Using the Spark submit command, okay, you call the Kubernetes API, and there is also a Spark operator. Okay, in my demo, I'm using the Spark operator. And so it's very simple. Okay, this is actually, okay, is not different from running any other workload in the Kubernetes. So the Spark submitters to the API server. Okay, the API servers, all right, in order creates a to create a job. A driver pod is being created. There is a controller tell to the scheduler, and then the driver pod is being created on the data plane. Okay, once the driver pod, okay, is ready, all right, okay, the driver pods request to the API server, okay, to have the executors. The executors are the one that actually running the job, okay. And when the executors, then the scheduler again, okay, creates the executors on the nodes, okay. And then once the nodes are ready, they are connected headless service with the driver. And then when the connection is done and the pods are running, then the driver tells the executors, this is a job that you should run for me. Right, but sounds complex, and what are the things, okay, that I should consider when I'm scaling Spark on the Kubernetes? I just to mention some of them. When you're running a Kubernetes in the cloud, okay, although I'm working for AWS, I'm not specifically, okay, talking about this. When you're running a Kubernetes in the cloud, you have to set up the VPC, okay, it's the virtual LAN, all right, into the cloud. And there, for the pods and the nodes are sharing the IPs. So it's one IP, one pod, okay? You have plenty of, and you'll have plenty of pods. So you have to make sure that you set up the VPC with enough IPs, okay, in order not to have IP exhaustion. Okay, one way it is to add a secondary CIDR. All right, a secondary CIDR usually with the subnets with the non-routable IPs. Okay, and then you are with if you have the cluster between two AZs, you have 120,000 IPs. So you have plenty IPs, okay, for your pods. Okay, so this is like one thing. Otherwise, you'll end up and you have to recreate the whole cluster because you don't have enough IPs. Or you can go bold and use IPv6 from the beginning because it is supported from 3.0, 3.4, all right, okay? And yeah, and then you don't have this headache anymore. Sorry about my breathing. Okay, all right. The compute options. Okay, what do we have for the compute options? Okay, so I mentioned the Spark driver pods and the executor pods. Okay, now you have to make sure that the driver pods, they are running on on-demand instances. Meaning, like, if a driver pod it is interrupted, the whole job, okay, has to restart from the beginning. And however, for the executor pods, you have the options either to run on on-demand instances, but also to run on the spot instances. Because if the executor pod is interrupted, then the driver creates another executor on another instance. Also, you can run both of them on x64 or ARM64 instances. And this is adding on top of the cost optimization that you can achieve running the executors on the spot instances, all right? Because usually the ARM64 instances, they are well known, for being high efficient, high performance, and also cost optimized. There are two types of autoscaling in Kubernetes right now. One is the well-known, the cluster autoscaler, obviously, and the other one is the Carpenter. All right, Carpenter is an open source project that was given to the open source community by AWS, for some time ago, and Carpenter, we highly recommend using the Carpenter over Autoscaler for the Spark job, for the Spark workloads. And this is also because it gives you the flexibility. You don't have to create managed node groups or self-managed node groups that you need to use, for the cluster Autoscaler. And in the same time, you can create dedicated provisioners, one for the driver pod, and you can tell that it should run on on-demand instances, and with the low capacity for the compute and the memory. And then you can have like another provisioner, for instance, for the spot for the executors on the spot instances. And you can define also, and I will show you in the demo, that it should run both on x64 or ARM64 type of instances. Obviously, then, you can leverage the Kubernetes using the node selectors and taints to tell to the driver pods and to the executors where they should run, on what type of instances. All right. You have the options also to configure the max number of pods that is running on the node, because usually, although it is like it will be a large instance, 50, 60 pods, of Spark jobs per node. This is the recommended one. And this is kind of the last bit of when we talk about the networking, the VPC. We talk about what kind of compute it is running and who is doing that. All right. The Kubernetes default scheduler is not enough and is not tailored usually for batch deployments. And the Apache Unicorn, which is an open source project, it's exactly giving you this because it's designed to handle the batch workloads. It has, I just want to mention several characteristics. So this batch scheduler offers features and support for many data processing and machine learning frameworks like Spark or the PyTorch. And in the same time, you can have, it is running in a multi-tenancy, all right, this and resource isolation. This is like another thing. And the second one, another important one, you can prioritize the queuing and for the jobs. And the most important, it has gang scheduling. All right. Gang scheduling allows you, to schedule the whole Spark application at once, and not like Kubernetes scheduler will do pod by pod. All right. So this is a gang scheduling. And I have it in my demo as well, and I will show you to you, when it's kicking in. Good. Where is the rest of the ecosystem? Because my presentation, I have other components in there. All right, so we have the Spark, we have the Kubernetes, we have the Carpenter, the Argo workflow. It's a Argo workflow. It's a DAG orchestrator, direct acyclic graph orchestrated. That is a workflow engine, and it's working the best. Because it's natively working with the Kubernetes. All right, there are also other options, but this one is natively working with the Kubernetes, and you can use it on almost ATL job, or machine learning, and you can easily also, obviously, integrate it into any CI/CD workflow. And Argo events, it is the one also that I'm gonna use it, and I'm gonna use Argo events because Argo events can capture an event from various sources, all right, and then will trigger an workflow, and the workflow will create a job. Okay. The architecture that and the demo that I'm going to show you to you, okay, pretty much looks like this. Okay, so for this demo, I'm going to use a Nikes cluster, and the event source that I'm going to use it, okay, it's an AWS SQS. All right, so I'm going to send there an event, and the event, okay, will be captured by the Argo events. That the Argo events then, okay, takes the event source, then add it to an event bus, okay, and then a sensor is listening on that event bus, okay, for events that are happening. Once the event is happening, a workflow is triggered, and that they will create a Spark job. Okay, and then the driver, the executor pods, you'll see how they will gonna be provisioned on that cluster. This is the link to the demo repository, and I encourage you, all right, okay, to have it. This is a part of the project that I'm contributing. It is the name Data on EKS, and it includes more, not about analytics. This is a blueprint that I was working on, okay, and along with others, but it has also about AI, ML, Gen AI, and streaming, and as well. All right. And now let's play. All right, I'm gonna stop this. And okay, let me find my okay. All right, okay. Briefly, this is the project. Okay, sorry. No, actually, I don't need this. Okay. So it has the here there the event source, the event bus that are defined, the Argo events manifest, and here I have I have this job, okay, and the job is like this. So a sensor, okay, from the Argo events, exactly like I told you, trigger an workflow in Argo workflow. All right, okay, this is the workflow, and here I can see that I have multiple jobs. And I have the first one that is hello world job, okay? And from this hello world job, then I have two jobs. One is the Spark operator Pi job. This is a simple one. And this is another one, a taxi job. Actually, the job itself takes the some taxi, let's say data from New York, all right, and I'm adding a column, okay, and this is processed inside of the Spark, okay, and then put it back, okay, the file is take it from this free bucket, put it back into this free bucket as well, all right, okay, and then when this will be finished, okay, they will be then closing down with another simple job, okay, like job done, Spark done. And these are the deployments. The first one, the Spark operator Pi, as you can see, this is an image, okay, and this, and then for the next one I will use a different image, and this one it's using on Spark Compute Optimized, okay. This is x64 instances, okay, and this is where the unicorn kicks in, and the second one is the operator taxi that has a different image, okay, and it is running on ARM instances, Graviton, as we call them in AWS. All right, okay, this is running on Graviton, and it will be in the same time. And now let me show it to you. Okay. Right. Let me see where I am. Okay, not good. Okay, okay, here. All right. Good. This is my queue. Okay, so I am sending a. Wait a minute. Oh, God. Wait. It's easy fixing. Trust me, I repeated this many times. What do I need? A QRL, yeah. When I did this, okay, with the, because I'm projecting something, it is different. Come on. Yeah, all right. So I sent a message. And what you're gonna have, you're gonna see, all right, okay, wait a minute. I need to show you something also here. It's something cool. Okay. And, okay, what do we have? We have here the first job, okay, that is being created. Okay, the one that is small one. And actually what I should do, I should make it a bit smaller. Okay. Hopefully I'm not gonna disturb anything. All right. And then a node has been created. Okay, that is the last one. All right. Okay. Now, as we progress, okay, with the things, okay. So if I look here, Argo watch. It's so annoying. Yeah. And when at some point, okay, right now, then the second job is being created as well. It will be starting pretty much soon. Okay, the wholesale has finished. Okay, and then the jobs will be created. Wait, I have a backup in here. I want it to be a CLI, but didn't work. But I have a backup in here because I have the workflow. All right. Okay. Soon the other pods will be, right, it's coming now. Is it? Yeah. Okay. Takes a while though. But then, as you can see here, new nodes are being created for 1 minute, a second, where I am here. Okay, and what should I do? One. All right, these are the pods, the driver, and they're waiting for the nodes to be created. See the drivers, and then I have the executors. And you can see here that I started automatically the nodes, okay, they're being created by the carpenter. And for instance, the first driver, now the executors for the first one, okay, it is already running, okay. And then I have the second driver that is running, all right. And unfortunately, you can't see there, but there are also ARM nodes and Graviton nodes. And more nodes, as you can see, they are being created as we progress. And because the carpenter, what is doing, comparing with the cluster autoscaler, he's looking for the pending pods. And okay, once you have the pending pods, as you can see here, I have 4 pending pods, then creates automatically the instance, okay, for these pending pods. So I have, okay, it is almost done. New pods, new workers are being created for the pods. And once all the jobs will be completed, and you will see that, then carpenter delete the nodes that has been created. And at the end, we will see that we'll have only we remain only with the core nodes. And yeah, all right. Okay, so first job has been created, has been completed. Okay, and now it is running on the second job. Okay. Some executors are already running. Some of them, they are coming. Okay, imagine that the instances are being created right now as we speak. So they are added as a nodes to the cluster. Okay, putting the pods on it, running the pods on it, everything. Okay, that is running, and then delete the nodes as well. All right. Okay, we're almost there, and we're also there. Okay, we have 2 more minutes. So we can use this time, okay, until this job is completed. For you folks, if you have any questions. Yeah, please.
Thank you for this presentation. I'm curious about the tool that you use to visualize
EKS node viewer.
Okay, so it's related to EKS only, right?
It's working with the EKS only.
Okay, thanks.
Yeah. All right. All right. Okay. So as you can see, okay, this is the now the pods are being cordoned. All right, because we finished the jobs in there, and I think I don't know. Okay, when we make it, all right. Okay, yeah. Okay, this is I couldn't see it. Okay, and this is the whole what I have done. Okay, so the Argo workflow sparked the first job, then 2 jobs was running in parallel, and then I have like the other job at the end. Okay. Thank you.